Hello guys, so we have already learnt about the distance between 2 points of a straight line and a point that cuts a line internally. So whenever you have the these x-axis and this is going to be a y-axis, so whenever you have the xy plane, whenever you have the xy plane, you're going to have 2 points. So let's say this point here is x1 comma y1, and let's say this point over here is x2 comma y2. Then the distance between these 2 points will be, the distance is given by, let's say if this distance is d, then the distance is given by d is equal to x2 minus x1 whole thing squared plus y1 minus y2 whole thing squared whole thing square root. So we have already learned this material, right? And furthermore, when you have a straight line, if this point here is x1 comma y1, and if this point here is x2 comma y2, then this point here is P. So this P cuts the line AB at a ratio of, let's say, m into n. Then the coordinates of this point, say x comma y, is given by the formula x comma y is equal to mx2 plus nx1 divided by m plus n, and the y value is given by my2 plus ny1 divided by m plus n. So this is what we have learned already. So guys, what we're going to now do is, we're going to think about a line that is going to cut a line externally, right? I mean a point that cuts a line externally. So now let's think about it. If you have the Cartesian plane, so this is going to be a x-axis and this is going to be a y-axis. So you have 2 points, right? You have 2 points. So this is going to be A and this is going to be B, right? So you have this line. So if a point cuts a line externally, then that point must be at a point. The point must be at a place where the line AB is being produced. So somewhere like this. So now the ratio between AP is to PB is what we need to think about, right? So the ratio between AP is, let's say, m, and if the ratio between BP is equal to n, now we're going to find the equation of the point P, let's say x comma y. So let's say this point here is x1 comma y1, and let's say this point here is x2 comma y2. So we're going to find this, right? So let's try to prove down the equation again, right? We're gonna use equiangular triangles again, but I don't think it's rather than finding equiangular triangles, it's very simple. It's very let's use equiangular triangle for a good understanding. So now you're gonna have 2 triangles like this. So this is going to be x, this is going to be y. So let's say this point is A and let's say this point here is B, right? So you are extending this line up to point P, where P is equal to x comma y. So now you can consider 2 equiangular triangles. Now this is a triangle over here. I mean AP, let's say APX is a triangle, and also APY is another triangle. APY is another triangle. So if you want to find, now the ratios are, how have they given you the ratio? AP is m, right, and BP is n. So that's how the ratio has been given. So the way they have given the ratio is AP is to PB is equal to m is to n. So that is how they have given you the ratio. So if you consider the 2 equiangular triangles PBX and PAY, you can write the formula like this. Now the distance over here, the distance, now this is x1 comma x2. Now this is going to be x1 comma y1, and this is going to be x2 comma y2, right? So the distance, so the distance between x and b, I mean the horizontal distance is going to be, I mean xb distance. So now from equiangular triangles, you know that xb over ya is equal to, now xb is a part of this, I mean pb over YA is a part of the larger triangle, so you're going to have PA. So that will give us XB. What is XB? XB is going to be x minus x2. So x minus x2 divided by x minus x1. So this is going to be x1, right? X minus x1, right, is equal to, now PB. Where is PB? PB is your n, right? So PB is your n, I think. Yeah, PB is n and AP is your m. So these are they have given you. Now if you do the cross multiplication, if you try to simplify, you're going to have mx minus x2 equal to nx minus x1. So now if you consider, if you expand this, you're going to have mx minus mx2 equal to nx minus nx1. So we have to subject x because x is the point that is, you know, that we need to find. So let's take n to that side, right? So you will have mx minus nx equal to mx2 minus nx1. So here x is common, so you have m minus n, so this will be equal to mx2 minus nx1. So x is equal to mx2 minus nx1 over m minus n. So this is going to be the formula to find the value of x. So m minus mx2 minus nx1 over m minus n. Now if you look at the pattern, now this entire large line is going to be m, the small one is n. So from n you are coming all the way to the opposite guy, n to x1. So larger guy goes to x2. Makes sense? From here you have to come to opposite. So from the larger guy you have to directly go to x2. So this is the formula for the line that cuts the this is the formula for the point that cuts a line externally. In other words, x comma y will be equal to, similar, I mean the if you look at the analogy, x will be equal to mx2 minus nx1 over m minus n, comma my2 minus ny1 over m minus n. So this is the formula. So this is the formula, guys. I really found I really found, you know, if you don't have this formula properly, you know, I just thought that you might fall in trouble with the problem. So that's why I wanted to give you the formula. So here we go with the formula. I think you can try out the rest of the problems. Thank you very much, guys.